Hi everyone, you're welcome to Success Arena Academy. In today's class, I'm going to be showing you the secret behind the specimen that is given to us for Waec in this year 2022. Many teachers have been looking for questions that is related to the specimen, but most of them we are getting some different questions based on the confusion that Waec has put in that specimen. According to my research on the specimen, I noticed that nowadays Waec is kind of cunning, so that they do give us specimen in school nowadays, so that teachers will not be able to guess the questions that they are going to set for the students. But the specimen given to us this year is different. What are they given? In our mechanics, which I'm going to be showing you the practical that is related to it today. They gave us this specimen. Number one, we have to provide a set of masses. Set of masses which is of 20 gram, 40 gram, 60 gram, 80 gram mass and 100 gram mass. These are the specimens given to us. That's the first specimen. The second specimen given to us, we have to provide a mass angle. A mass angle. Number three, we have to provide a piece of string. That means one single string. Number four, we have to provide a meter rule. And number five, we have to provide a weighing balance. Then the sixth thing we have to provide is the knife edge. We also have to provide this knife edge. Now, normally we're meant to understand that whenever they are asking you to provide a knife edge, a meter rule, we know that the question that they are going to set under that should be how to verify the principle of moments, which is stating that the anti-clockwise moment should be equal to the clockwise moment. But the condition that is there is that we also provide a mass angle and you also have to provide a string. What is the function of this mass angle? But I want to tell you that there is one thing that it kind of omits in that question. According to my research, when I cross-check questions that have been set for the past in Waec, we noticed that they said the same thing in year 2020, which they gave us this same set of apparatus, but the problem behind it is that they never give us retort stand for the question. Now, for this year, we are not given retort stand. So, you see, I noticed something that I believe that many schools should have retort stand available for any experiments. Maybe that was the reason why retort stand was omitted. But I'm sure that this might not be the exact question, but it is highly 70% of the question. That should be 70% sure that this is the question that will be given to us, while 30% is that it will be the question, but note that you are only meant to determine the principle of moment. The diagram might not be like this, but it should surely be the principle of moment. Now, if you are new to my channel, please don't forget to subscribe to my channel and click on the notification bell to on the notification so that you can receive notification whenever I release a video, and also share the video with your friend and like my video. Thank you. If you have any comment, drop the comment for me in the comment box section. I'll be waiting for your comments. Thank you. Let's start. Now, when we are given set of masses. We have our set of masses here. That is mass of 20 gram, 10 gram. I think I have 20 SS. This mass here is of 50 gram. I couldn't find 100 gram mass, so we can provide multiple 50-gram masses for the experiments. Now, let's take a look at what we want to do here. And also, we also have our mass anger. Yeah, the mass anger actually that we have to provide has something to do in this experiment. Now, when I cross-check the 2020 past question that is set for them, I noticed that they gave them this same diagram, mass, which here I'm representing the mass anger as the unknown mass my that is given to us in the experiments. Now, we are given different masses in that same year, mass 20, 40, 60, 80, 100. But that year, they tend to change it for you. By changing it, the same year, that year, they only put mass 40, 60, 80, 100, and 120. There is no 20. But this year, they tend to put 20 grams for the masses. So, they are still going to repeat the same thing, because in this experiment, we have our knife edge, we have the meter rule. Now, what is the function of this knife edge? Now, the knife edge that we have to provide is only meant to determine the center of gravity of the meter rule. So, the first thing I need to do in performing this experiment is that you are going to take your meter rule, place your meter rule on the knife edge to determine the center of gravity. That means find the balance points of the meter rule. The balance point, according to this, my own experiment that I did, the balance point of my meter rule is at 50 centimeter. The meter rule is balanced at exactly 50 centimeter. That is the balance point. Now, what is the question given to them that same year? They said, you are provided with a meter rule, a knife edge, set of masses, a piece of string, mass anger, and other necessary apparatus. Actually, I framed this question also myself, but it is from the same year that I framed it out. Now, question 1, it said, place the meter rule on the knife edge. That is the question 1. Then, the next thing, read and record the point G. That is the first step. Take your meter rule, place it on the knife edge, read and record the point G. This point G simply means the point of center of gravity. Now, determine the center of gravity first. Now, when I read and record the center of gravity of this meter rule, I notice that the center of gravity is at 50 centimeter mark. That is my center of gravity. The next thing we are given in this question is that they said, where the meter rule balance horizontally as shown. Now, suspend the meter rule at G. After you record the center of gravity of the meter rule to be equal to 50, then we are going to take the string. This is my string here. Tie it to a retort stand. Then we are going to suspend that string at 50 centimeter mark, which is the center of gravity. Make sure that it will balance horizontally. If the center of gravity of this ruler is 50 centimeter, automatically this ruler is going to balance horizontally at the same 50 centimeter mark. That is the first thing that we have to do. Then the second thing is suspend the meter rule at G with the aid of the string, blah blah blah. Attach the string to the retort stand, support as shown in figure B. Then keep the string attached to this point. That means make sure that this string is not leaving the same 50 centimeter mark to avoid error due to parallax. Make sure that my string still remain at the same exactly 50 centimeter. Then the next thing, we have to attach the mass M knot, which we don't know. But my mass M knot that is we are using here is the mass anger. Please, I'm so sorry, I need to digress a little bit. I'm sorry that the question, what you might be seeing online before, based on the Waec specimen, was changed. Because when they released the Waec specimen yesterday, which was even given to us in public school yesterday, when they released it, we noticed that they've changed some things in the specimen. So what they brought initially was different from what we now have now. So that's why I need to make research on questions that is related to this. Now, let's take a look at this. Let's continue. Now, I balance it at exactly 50 centimeter mark, which is this my 50 points. Now, when it is exactly balanced, the next thing we have to attach the mass M knot at 80 centimeter mark. This is my 80 centimeter mark. Then I make sure that I tie this thing exactly, make sure that it is well taut to 80 centimeter mark. Then I placed it at 8 centimeter mark, exactly 8 centimeter mark, so that it won't be able to shift up and down, to not move from one point to another. This is the 80 centimeter mark exactly. Now, the next thing we are going to do is that They said determine the distance y of m naught from G. Now, actually, if you look at this diagram from here, this is when it is being balanced to get the center of gravity. This is the string and the whole combination. Now, this is the 80 centimeter mark given to us in this place here. Now, we have to determine the distance from G to this 80 centimeter mark. Now, when I calculated the distance, which is my distance y remained 80 minus 50, which is equal to 30 centimeter. Please note something. Because we are given in the question to determine it, then you must write it out when you are to report your experiment. If you don't write this out, it's going to lead to deduction of your mark. Now, we are asked to write it my y to be equals to 80 minus 50, which is equals to 30 centimeter. I think I've gotten that one. Now, the next thing in my experiment is that suspend the mass m, which is 20 gram. That is the initial mass. So I need to bring a 20 gram mass. Oh, sorry, I think I will miss something. We are also given a mass angle. Here we are using a manual mass angle, whereby this mass angle, we make use of it to determine the mass of this mass angle. Sorry, we have to determine a weighing balance. A weighing balance. So we make use of this weighing balance to determine the mass of the mass angle. That is what we use that for. Now, you might be given an electronic weighing balance in your own school. So the same thing, you'll be given an unknown mass to determine the mass of that unknown mass using the weighing balance. So it has something to do with that. All together. Now, here they said suspend the mass 20 gram on side AG. Now, if you take a look at this diagram, we have A to G here and G to B here. From A to G, the ruler given to us is 0 to 100 centimeter, which is this exactly 0 to 100 centimeter. Now, if I place my value here, which is on side AG, this side AG, place the mass of 20 gram here. Now, this is my mass 20 gram. If I have mass 20 gram, let me say this is 20 gram, I can place it exactly at this point here. This is mass 20 gram. The next thing, we need to look for the balance point. You notice that when I place my 20 gram, it tends to move towards this direction. Then what will I do? I'll need to find the balance point of this mass 20 gram such that this thing will be horizontal. Then, how do you get it? Now, it is moving to this direction, showing that the mass in this place is more than this. Actually, they might be of the same mass, but the distance of this one is more than this. Then I can try to shift it a little bit backward so that to have what? Balance points where the body will be balanced horizontally. Now, if I cross-check this, you notice that for mass 20 gram, this body is balanced exactly at 22.5, which is the point of balancing of the body horizontally. So if I take a look at this, I have 22.5 centimeter mark, which is here. I think here is 20, 21. This is my 22. This is 22.5. You are going to look for where you are going to have horizontal, whereby the body will be what? Horizontally stable. Now, if I take a look at this, you notice that the body is already what? Horizontally stable. Then I'll now look for the point at which this body is horizontally stable. Now, actually, there should be a change in this my value, because here we have the body is balanced at 22.5, and here we said 20.0. Here should be, for mass 20. For mass 20, the body is balanced at 22.5. Now, if the balance point of the body is 22.5, which is here, let me say we have the balance point as 22.5, then we can determine the distance of the balance point from the center of gravity. Now, what will be the distance of the balance point from the center of gravity? How do we get it? You know, the center of gravity that you got from your experiment is 50 centimeter. So if here is 50 centimeter and the balance point of the meter rule is 22.5 centimeter, now the distance from here to here should be 50 minus 22.5, which is going to give us, from my calculator, I have 50 minus 22.5, which is going to give us 27.5 centimeter. That means the distance S, I need my distance S. My distance S is 27.5 centimeter, which is For mass 20 gram, I have 27.5 centimeter, which is this. And don't forget that if you want to tabulate your reading, I'm coming back to explaining this. Now, we have 27.5 centimeter. I'll need to change this value also, which is S inverse. And my S inverse simply denotes S inverse is equal to 1 over S of my experiment. That should be equal to 1 divided by 27.5. And I'll be having 0.036, not 0.034, 36. Now, let's continue with the experiment. That's for mass 20 gram. The next thing is for you to look for mass 40 gram. You can easily get that by substituting this 20 gram or adding another 20 gram to this 20 gram mass here. But if I add 20 gram here, you notice that there is the balance move. It is unbalanced because the whole weight of the body is shifted to this place. Then I can make it to balance by returning. If the weight is coming to this direction like this, then you need to return the distance like this to make it balance. So if I move this thing like this, it's still coming to this place, showing that the whole weight is subjected there. Then you can still move it forward. Still coming, but try to check your balance point very well and make sure that this thing returns to exactly 50 so that you can get the exact balance point. Then if I put here, now I can still move this thing forward. I think I have. Okay. So, if we move this, just make sure that you move it to the extent that you are going to get the exact horizontal balance point, which is already balanced now. Now, after you've gotten the exact horizontal balance point, please take note on this. One of the major precautions that you need to put when you want to write down your precaution is that you need to avoid draughts, which is your DROUGH. Now, you need to avoid drought, and this drought is caused by wind. Now, this thing might not be balanced when there is wind blowing in a different direction. It might change the balance point of the meter rule. So you should put that in your precaution that what I avoided droughts when taking my reading from the meter rule. That is one thing because of wind. So wind might disturb the balance point of the meter rule. Now, exactly how do I get this? Actually, when I got the balance point, let me say what I got here is 36.5 for instance. Actually, I already calculated it, but you can also make yours when you get there just to show you how it work. Now, the balance point here is 36.5 centimeter, for instance. Now, then to get the distance, don't forget that from your diagram, this is your distance S. Where it's balanced to the center of gravity is my distance S. Your distance Y remains constant, which is already calculated here. So my distance X is here, and I can get my distance X by subtracting 50 minus your balance point. Anything you get, that should be your distance X. So here, actually, I have 14.50 as my distance X. And when I calculated forward, the same thing goes to 60. So when you are doing that of 60, I can easily do it like this by just only removing this 2020 masses from here, replace it with 50 and 10 mass gram. So when you added these two together, I think I have 60. So if you join these two together, you're going to have 60 mass. Then you look for the balance point. But note, for it to balance, you need to move this thing a little bit like this before it can balance. So I think we make use of that to get the whole experiment done. For 60, you're going to do that. For 80, you'll be adding 50 gram mass, 30 gram mass. Sorry, you can't have 30 gram. 50 gram mass, 20 gram mass, and 1 gram mass to 10 gram mass. Join them together at this point here to get your 80. While if you want to get your 100, you might be provided in your school. they can give you exactly 100 gram mass. But if you are not given that, you can use 50 gram mass to make 100. So in getting that, after you've gotten the experiment, we now come back to this. This x inverse, according to your indices, s inverse is given as 1 over s. So I can make use of this 1 over s to calculate this is my s in centimeter. Now, 1 divided by each of these will be giving me s inverse. How do I know that we are going to tabulate my s inverse and my s? You can easily know what you want to tabulate from your question. From the question, it said, measure and record the distance s of mass from G. Now, since you are given varying masses, different masses, automatically the distance s should be what? Tabulated. And your distance should be in centimeter. Why in centimeter? Because the ruler that you are using is in centimeter. Note that. Now, the next thing that I need to do here is that when you are tabulating, the second thing we have to find, they said evaluate S inverse. That means, you know, I might have different value of S due to different value of M. Since I'm getting different value of X, automatically my S inverse should be able to be what? Tabulated. Now, when I'm tabulating this reading, I have 27.50, which is 1 divided by S. I'm going to have 0.036. 1 divided by this 14.5, I'll be having this. This divided by 1 divided by this, we're having all this. But to make your graph easier, okay, before I go to the graph section of it, you notice that when I want to put my table, I need to put the units at the top. Mass representing what? In gram, S in centimeter. Now, what I'm telling you is that, you know, here you have to find S inverse. Automatically, if you have to tabulate, you have to put centimeter inverse here to indicate that my S is in centimeter, but here is centimeter inverse because of that inverse. Now, actually, the one in this side here is we are not asked to tabulate this. But to make your graph easier, it is better for you to put your value in whole number. Remove it from decimal so that you can easily calculate, you can easily get your scale. That's an easy scale to use. Now, how do I do that? Now, see what I wrote there was, I converted this to standard form. You are allowed to do that in Waec. Convert what you are given in decimal to standard form. Now, this is 0.036. I want to convert to whole number. Then I converted this thing to what? 1, 2, 3. That is 36. Sorry. I have 36.0. Sorry. We have exactly 36.0. But here, I need to show them what I'm doing. So anything you want to do, you need to indicate on your table that you've done so thing to this. Without that, they will deduct your mark. Now, I try to tell them what? S inverse times 10 is power minus 3. S inverse times 10 is power minus 3. I'll be having something right here. I think I'm trying to get 0.036 in standard form to make it to be 36, ordinary 36. This thing should be equal to 1, 2, 3, which is what? 36 times 10 is power what? Minus 3. All together. Now, that's what I did here. So, what I'm making is that I'm trying to show that what? Everything here has been converted to 10 is power minus 3. But you can't write this thing in your table by now writing 10 is power minus 3, 10 is power minus 3, 10 is power minus 3, all true. The only thing you can do is that what? Since everything is going to have 10 is power minus 3, it is advisable to put it on top of here that what? 10 is power minus 3. It simply shows that what? My same S inverse, I've converted it to what? Standard form by writing it to 10 is power negative of 3. So I'll now be having O number, but your units still remain the same, centimeter raised to power minus 1. You don't change because the value here, that's what you're having in this place here. Also, if you are to draw your graph, I'll be showing you how you are going to draw this in your graph also. Now, that is that for that. If there is any question that you don't really understand, you can drop it to me in the comment box section. Please comment by dropping anything you like. Just drop the comment for me. I will show you reply your comment. Now, this is for this. Another thing I want you to note when you are plotting this, I will go to how to plot the graph exactly for you. I'll show you the next thing here. You know, they said, I think, tabulate your reading, plot your graph. Now, many students don't understand this, that if you are plotting your graph, make sure your graph rhyme with each other. you know, say I'm using one decimal here, I make use of one decimal throughout, two decimal throughout. This one is what? 3 decimal. You don't have here as 2 decimal, then you're not putting this at what? 3 decimal. You are writing what? Wrong value. So I think for now, this is this for the table and everything. So I will be showing you next now how to plot the graph of this table. Now we are going to be looking at how to plot the graph. As you can see on the board, we are given a complete physics graph board to plot the graph of this table here, which I'm going to be showing you how to get it. But the first thing I need to explain to you before plotting the graph is that if you want to plot the graph of this, actually the question says we plot the graph of M on the vertical axis and the graph of X inverse on the horizontal axis, starting the both axes from the origin, OO. Now, how do we go about this? Now, I've already made sure that my S inverse is moved away from decimal into an whole number to make my scale easier. Now, my masses, I have 20, 40, 60, 80, 100. Now, I'm going to check which of them is the lowest value. The lowest value I'm getting here is 20. The highest value I'm getting here is 100. So that if you want to choose a scale, your scale should be in the range of that value. Now, if you take a look at your S inverse, I have 36, I have 69, my highest value is 175, and my lowest value is 36.0. Now, how do we go about this? We can go like this. I have my ruler to plot it. You can just draw using your ruler. That's, we have here, starting from here, let me use a red pen so that you can understand what I'm doing. So we have here, this is it here. I'm not sure this thing is kind of showing very well. So we have this, sorry. So we have this. We are going to make sure that you draw your line. Get this line out first. Now, I've gotten my line, which is this line. Then merge it, this one. I have the second line. So the line at the bottom right corner here, which I'm going to be using blue marker to represent. Sorry, trying to follow this axis. Now, this is my third line. This is my first line for the graph. Now, we have this line and this line, which is my vertical axis and my horizontal axis. Now, I'm going to label each of these axes. You know, you have to plot mass M on the vertical axis. You can label here as your M into gram. G to represent your what? Your gram. Y, we have to provide this in the horizontal axis, which is my X inverse. But if I want to write my X inverse, we have to find this on the horizontal axis. This is my X inverse axis. That is, sorry, please, if you want to write, because of the graph, you put it at the bottom here. So we have S inverse into brackets, sorry, no, let me put times 10 raised to power minus 3. That is the value I'm using here, times 10 raised to power minus 3, according to what you have in your table. Now, and the unit should be beside it, which is centimeter inverse. That is the unit at the bottom there. Now, let's now try to fish out the scale we are going to use. Now, which scale will we use here? Don't forget that another thing that you don't need to omit. If you have to plot your graph, please do not omit the origin. The origin given to us here is 0, 0. That is our origin, 0, 0. And we have the X inverse axis, the mass in gram axis. Now, the next thing we should do is what? Check the scale. If you look at the mass, you know, it is quite easy, 20, 40, 60, 80, 100. You can try to not bring the exact value here into your graph. Just try to use your own value. I can use as much as possible, but just know that any value you want to use, make sure that that value will be there such that your graph will contain 80% of the graph book. So from here, I can use, if here is my origin, 10, 10, here should be 10, here should be 20, here should be 30, here should be 40, 10, 20, 30, 40, here should be 50, here should be 60, and I should be having 70, 80, 90, and the last part of it here, okay, let me try to bring this out. That is my mg. So here should be 100. 100. The last line here should be 100, which is my last value. I think that's okay. But please note, if your graph does not contain that same 100, you can use larger value like 20, 40, 50, 20, 40, 60, 80, 100. But make sure that if you are to write your scale, it should cover the whole graph book, and this should cover your words bottom also. Now let's try to look at the value we can use for this. Since I have the lowest value here as 36, the highest value as 175, I can easily make use of this using 20, 40, as in 20 centimeter to represent 40 units. 20 centimeter to represent, 2 centimeter to represent 20 units on this axis. What I'm using here, I'm using 10 centimeter, 2 centimeter to represent 10 units. Where is the centimeter? Many of us don't understand what we mean by what centimeter. If you take a look at this board here, I notice that these small boxes, you see it in your graph. These small boxes, if you count it, it is 10, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That 10 boxes denotes 2 centimeter. It might be given, the kind of graph that you might be given in your own school might be the one of 5 boxes. If it is 5 boxes, that means I have 1, 2, 3, 4, 5. That is 1 centimeter. 5 boxes denotes 1 centimeter. 10 boxes denote what? 10 boxes denotes 2 centimeter. Now from here, I have what you are writing here is representing your units altogether. So here I can have 2 centimeter to represent 10 gram. Don't forget that it is units. 10 gram, 2 centimeter represents 10 gram. While here, 2 centimeter is representing 20 centimeter inverse. Why? The unit there is centimeter inverse. So in mathematics, you can make use of 2 centimeter represent 2 units. 3 centimeter represent 3 units. What is the function of that unit? Substitute your unit there. So what is my scale here? 2 centimeter represents 10 gram. While here, 2 centimeter represents 20 centimeter inverse. Now, let's put our value of this here. I should be having the next value here. This 0. Here should be 20. Here should be, here is 20. And here should be 40. Okay, let me use 40, 60, 80, 100. Here should be 120, 140, 160, and then I have 180. And we can put S inverse times 10 is power minus 3 in that place. So here is 180 centimeter. 180 centimeter. That's what we have in that side there. Now, these are our exact value given. Sorry, the board is kind of unstable. So these are our exact value we are given here. Now, so we have here as this. This is my value. Now let's try to make the value together. Now here they said when the mass is 20 grams, the value is 36.0. Now, how do we read on this? For mass 20 grams, this is my mass 20 grams. S inverse is 36.0. How do you calculate it? I need to find, if here is 20, each of these small bosses represent 2 centimeter inverse. How do you know that they represent 2 centimeter inverse? This is it here. Since the centimeter of this thing is 2 centimeter altogether, and we are making use of 20 centimeter inverse. So to know what each boss represents, that is 20 divided by the 2 centimeter, which is this 10 boss. 20 divided by 2 centimeter, 20 divided by 10 bosses, then each boss will be what? 2. Since we have 10 bosses, and each of these from here to here is 20. So to know the value of each bosses, that is 20 over 10, which will give us what? 2. Now, from here, I have this one to be 2. So if here is 20, here is 20 and 22, 24, here is, 20, 22, 24, 26, 28, here should be 30. This place here should be 30. If I'm reading it like this, 20, this 20, 22, 24, 26, 28, and 30. Here should be 32, 34, and 36. This is my value of 36 here. Now, if this side here is 36, here is 36, and we said 20 to 36. Now, this is my 20. I can merge this to this place here. At this point here, you can use any style. It's either you make use of a dot and a circle to represent it. A dot and a circle. This is my 36. Now, the next one we have 40 to 69. How do you get your 40 to 69? Now, this is my 40, this is my 60. I'm going to calculate it to get to 70. Yeah, this is 60. Sorry, let me use top. 60, 62, 64, 66. You know, here is 68, here is 70. 69 should be between 68 and 70, which is the middle point of 68 and 70. That is my 69 should what? Lying at that point. Now, you know it is 40 to 69. Trace your 40 to that center point of this, which is supposed to be here. That is the value there. Now, I should have here. That is my 69. The next one, we have 60 to 105. Now, how do we get, this is my 60, 105, this is 100. But if I calculate it, I should be having, this is 100, 102, here should be 104, and here should be 106. So my 105 will be lying between 104 and 106. So, which is traceable. If I trace it out, I should be having 60 here, which is here. Now, I'll be having my 60 around here. So, 60, 105, take a circle, also to denote it. Now, the next one, we have 80 to 143. Now, this is 80. Where is my 143? Go straight to your 140. This is 140 here, 140. If I trace it, if here is 140, here should be 142, here should be 144. 143 will be between 142 and 144, which is, I can say, okay, this is my 140. Let me just use this so that it can be easier. We have 80 to 140. Let me trace it to 80. This is 140 exactly. Now, if here is 140, here is 142, here is 144. 143 should be at their middle here, which is 143. That is my value of 143. Now, we have gotten that. The next one is now 100 to 175. Now, where will we get our 175? If here is 160, let me say this 100, right? This one is 160, from the ground is 160. Here is 180. If here is 160, I should be having here to be 162, 164, 166, 168, and this one is 170. So if here is 170, I'm going to 175. Here should be 172, 174, and 176. My 175 should be lying between 174 and 176, which is somewhere here. Now, we are not going to find the three best line of fits. The three best line that is a straight line. That's what you're going to look for among these lines here. Find the three best line of fits. If I take a look at this, but if you are to do this, please make sure that you are using a long ruler. To do that, make sure you are using a long ruler. Then I should be having this. Let me try to use this. Sorry that my ruler is not that kind of long, but we are going to manage it. So we have these three lines. One, I have this line, one, this point, and this point. There are three straight lines. These points, and this point. They gave me three straight lines. Then I can easily draw my straight line out from there, touching the 3 points. The straight line is touching the 3 points. Take it back to the origin. Take a look at this. They are moving back to the origin because it is a straight line graph. So we turn it back to the origin. I'll be having this, and this. That is the graph for us. Now, we've been able to plot our graph by taking the three best points, 1, 2, and 3, which is a straight line. Now, after you've gotten your line of fits, the next thing is now for you to calculate the slope of the graph. You can calculate your slope of your graph on the table. Now, let's take a look at here. Let me just try to rub off what is here to get the slope. Okay, now, sorry. I can use my slope from here. So, I should have something of this kind here. Sorry for this. Okay. Now, I have this place to calculate my slope. Now, how do we find the slope of the graph? To calculate for the slope of the graph, I'm going to pick, since that you have a straight line graph, pick any point from the what? Straight line. But note that if you want to draw your slope, make sure that it is a straight point. If I pick this point here, I pick that point to draw my slope. Just make sure that it is a little bit large. And I pick somewhere that will be easier for me. Let me try to use this place. This point and that same point. I'm using here and I'm using here, but at least it is what? It will cover 80% of your graph. Now I can draw a straight line using, let me use my red pen here. I have straight line. We are going to draw this one down. You know, we have 2 points. This is my next point, right? This is my second point. This is my first point. Is it a little bit big? That is not kind of big. Okay, but just make sure that what is a little bit bigger. So I have these points. And these points. This is my slope. I have these points. This is the point I'm choosing. And I'm what? Choosing this same point here. Now, join these points to this point here. Now, what you will be having on your slope here, I can just easily say that what? Since here is denoting S inverse, just say this side is denoting S inverse. Sorry. So I have S inverse. Now, this is denoting S inverse, so you can just put it as what? Change in S inverse times 10 raised to the power minus 3. Because you know you are using 10 raised to the power minus 3 here, the unit should also be here in centimeter raised to the power minus 1. And this side is your mass axis, so I can use here as my change in M, which is my unit is in what? Gram. Change in M, which is in gram. Now, your change in M, that should be M2. So let's come back to this place here. My slope should be equal to change in the M all over change in S inverse. That is my slope. Now, how do you calculate for this? Then you can easily find this. What is your change in M? Trace this point here. You know, this is the initial point here, right? This is the initial point here. Now, this is another point. In mathematics, we can find the coordinate of this point. What will be the coordinate of this point? Coordinate of this point is the value of this point along X and its value along Y. Now, what is the value of this point in this place here? We can take it, if here is 30, here should be 30.5. 30.5. Here, if I want to draw the distance of this, I'll be having here. Sorry, let me use this big one. Now, the coordinate of this point along here should be 60. So, it is 60, 30.5. That is the coordinate of that point. 60 in the x-axis, x inverse axis, 30.5 in the y inverse axis. Why the coordinate of this point here? If I take a look at this point is what? 80 in the y-axis, in the m-axis. While here it is kind of 140. So if I draw this one, coordinate of this point is 140, 80. Now 140, 80. I've gotten the coordinate of that point and the coordinate of this point. And in mathematics, you know, let me just chip in coordinates. Coordinates simply means this one here is my y2 of m2. This one is my what? m1. This one is s inverse 2. And this one is s inverse 1. So my change in m is m2 minus m1 over s inverse 2 minus s inverse 1. Are we together? Now, what will you have in this place here? But if you want to write your slope, please take note that you have to write your slope by putting your 10 raised to the power minus 3 for your s inverse. Don't forget that it has 10 raised to the power minus 3, so you are going to include it back when you have to write your slope. Now, what is my m2? My m2 is 80. 80 minus my m1 is 30.5. 30.5 all over my S2 inverse 140 minus 60. 140 minus 60. Everything times 10 raised to the power minus 3. Because there is 10 raised to the power minus 3 in that place. Now, I should be having what? 80 minus 30.5. I should be having, I think, 40.5. No, sorry, 49.5 all over 140 minus 60, that is 80 times 10 raised to the power minus 3. 80 times 10 raised to the power minus 3. That's what I'll be having. So, if we take a look at the slope here now, I will now be having this. Sorry. Blah, blah, blah. So, if I have 49.5 divided by 80 times 10 raised to the power negative of 3. Then I'll be having 618. That is S to be equal to 618.75. 618.75 I should be having 618.75. Okay, that is our value of the slope. Now, the unit of this, you are going to include the unit of this thing there. Now, you know, this one is in gram, the mass is in gram. Sorry, I'm trying to cross-check something out. Okay, if I have this, gram per meter, okay, yeah. So, the mass of this is in gram, while this one is in per meter, h to the minus 1, okay, per centimeter, yeah, sorry, gram centimeter. Now, why is it gram centimeter? Because this place here, the unit of what is here, let's try to calculate it out. We have a unit of mass in gram, but what they gave to us, our x inverse here, is in centimeter inverse. Meanwhile, moment should be gram meter. Altogether, force times distance, gram meter. So here, we have what? Per centimeter. If I use division, according to mathematics, this inverse will become gram into what? Centimeter. That is the value, which is equal to 618.75 gram centimeter. That is our slope. And your slope should denote that moment, because moment is the product of force or your weight and the times the perpendicular distance, which is what we have gotten in this place according to what is given to us. Thank you for watching this video. Please don't forget to subscribe to my channel and drop a comment for me in the comment box if I'm sure that what this should be helpful for you, and also try to share this video with your friends and family so to get best grade. See you.